Hello friends, this video on equilibrium part 35 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. So we have discussed the effects of change in concentration, temperature, pressure for equilibrium change. Now let's discuss the effect of ionization, effects of ion addition. You add some ions in the already ionized acid base. You see this is the equilibrium actually, this is the equilibrium. And this you are changing the concentration by adding ions. So if you add some, let's suppose acetate ions, if you're adding acetate ion, what will happen? So you're adding more ions here according to Leach order principle. The stress of addition of acetate ion will be released only when the reaction moves in this direction, right? So the reaction moves in this direction, what will happen? The H plus ions also is used. So the concentration of H plus ions also goes down, right? So if you want to decrease the pH, or if you want to decrease the acidity of this solution, if you add this acetate ion, what this guy will do? This will this will force the equilibrium to move in this direction, and thus it will consume H plus, and the H plus ions will also go down. Similarly, now if you add this H plus ions from the external source, then also if you see, it will move in this direction because the stress of adding H plus ions can be relieved only when the equilibrium moves in the left direction, and then there also if you see the acetate ion concentration is less and the acetic acid is formed more. So the effect of ion concentration, you don't have to think a lot on this, just assume this as the effect of concentration change. So in concentration change in equilibrium, we have discussed this. Use the same logic. Ions is nothing but a species in the reaction. Assume that as a species and just add this. Let's suppose H plus. What impact it will have? It will obviously move the equilibrium to the left hand side, and this the concentration of acetate will decrease and acetic acid will be formed in large quantity. Right. So common effect ion, if we don't define it, is nothing but shift of the equilibrium on adding a substance that provides more of an ionic species already present in the equilibrium. So if this is equilibrium, there are some ionic species which is there in the equilibrium and which is part of the equilibrium. You provide some more ions. In that case, the equilibrium shifts in the left side. And if you remove, let's suppose H plus ions here, the equilibrium will sit in the forward direction. Let's take some examples of the effect of ion effect. So we have to calculate the pH of the ammonia, 0.1 ammonia, and we have to calculate the pH after 50 ml of this solution is treated with 25 ml of HCl. And the dissociation constant of ammonia is given. Correct. So I have ammonia is the base. It reacts with water. It forms an equilibrium, and it forms NH4 plus and OH minus. Right. So at T is equal to 0, it was 0.1 m. So it was 0.1 m. This was not required. This is 0 and this is 0. So at T is equal to equilibrium, this becomes 0.1 minus x. Not required, this becomes x, and this becomes x. Right. The first thing is you calculate the pH. First pH, initial pH. Let's talk about this line only. You find the pH of this. So you find the OH minus concentration. Let's do that. So we know that Kb is equal to what? Ammonia concentration, that is x. OH minus concentration is x by ammonia concentration is 0.1 minus x. So NH4 plus concentration, OH minus concentration, and NH3 concentration. So this is nothing but 1.77 into 10 to the power minus given Kb. So if you solve this is nothing but x square by 0.1 minus x is equal to this. So if you solve this, you get x as 1.33 10 to the power minus 3. And what is x? Nothing but OH minus concentration. But I have to find pH. I have to find H plus concentration. So H plus concentration is what? 10 to the power minus 14 by OH minus concentration. Correct? Because H plus ion concentration into OH minus concentration is nothing but Kw. So with this, it becomes 10 to the power minus 14 by 1.33 10 to the power minus 3, and this is nothing but 7.51 into 10 to the power minus 2. So pH will be what? pH will be minus log of 7.51 into 21 minus 12, that is 11. This is my initial pH. This is my first part. Correct? See, now the trick begins. Now what happens is, in this we are adding 50 ml of this solution with 25 ml of 0.1 mHCl. So let's take the fresh page now. This part is done. Now comes the trick part. So you have to find the pH after 50 ml of this solution is treated with 25 ml of 0.1 mHCl. So we have 25 ml of 0.1 mHCl. This is nothing but my 25 ml by 1000 into 0.1, that is 2.5 by 1000 moles, that is 2.5 millimoles. So this of I have H plus, actually you can see, right, from HCl, and this reacts with, I have 0.1 into 50, right, so 50 ml of 0.1 mNH3. This is nothing but 50 by 1000 into 0.1, that is 5 by 1000 moles, that is 5 millimoles of NH3. So NH3 plus HCl, if you see, it's a neutralization reaction. This becomes NH4Cl, right? So that means I can say that my 5 millimoles of NH3 and I had 2.5 millimoles of HCl, actually, right? HCl we have. So this neutralization reaction will happen and we'll get only 2.5 moles of NH3. From this, if this react, we get net 2.5 millimoles of NH3. Why? Because we had 5 millimoles of NH3. Out of that, 2.5 millimoles consumed by HCl. Correct? So let's write the reaction once again. I have NH3 plus same reaction, NH3 plus H2O, or let me write here only. NH3 plus H2O gives NH4 plus OH minus ions, right? So this is now my 2.5 millimoles. Now I have to find in molarity, right? Moles per volume. So total volume is what? So total volume was 25 ml from HCl, 50 ml from ammonia, that is 75 ml. Correct? So let me find the concentration of NH4 plus now. NH3, let me find NH3. NH3 initial molarity. This will be what? Moles per liter. What is the moles? 2.5 millimoles. And volume is 75 ml. Right? And that is nothing but 0.033 ml. So this is millimoles. Right? Also with this reaction which we just saw, NH3 plus NH4Cl, this becomes NH4 plus, right? This is the same, NH4Cl. So let's find the concentration of NH4 plus also. This will also be same, right? Moles per liter, this will become 2.5 millimoles by 75, that is 0.033. Because you see, in this case only the same, because 2.5 millimoles of NH3 left and 2.5 millimoles of it is used, right? So this is 2.5 millimoles used. So we got this concentration of NH4 plus now. So now we have Kb. Let's have this reaction now here. So NH3 plus H2O gives NH4 plus OH minus. So T is equal to 0. We have NH3 was 0.033 m. This ignore, and this also we had 0.033. This is 0. At t is equal to equilibrium, this will become 0.033 minus y. This becomes 0.033 plus y, and this becomes y. So write Kb. Kb is nothing but 0.033 plus y into y by 0.033 minus y. Right? So let's assume these are almost same. 0.033 plus y and minus y are almost same. The y value will be very less actually. And this Kb is given as 1.77 into 10 to the power minus I. So with this, I got y as 1.77 into 10 to the power minus 5. Very small value. Correct. So I got the value of y, and y is what? My OH minus concentration. Correct. I have to find what? H plus concentration, and that is what? 10 to the power minus 14 by OH minus concentration, and that is what? 10 to the power minus 14 by 1.77 into 10 to the power minus 5. This value. You solve this, you get 0.56 10 to the power minus 9. I have to find pH. pH is nothing but minus log of this value, H plus ion, that is 0.56 10 to the power minus 9. You solve this, you get 9.24 as the answer. Little tricky here. The trick here was, the moment you add HCl to it, it has consumed the OH minus from here and created NH4 plus also. So when we are starting this reaction, we are assuming that NH3 has this value now, and NH4 plus also has this value now. Initial concentration. Correct. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.